D-minus 10, 9, 8.
So now I'm taking the samples that we prepared and I'm getting ready to actually run them in the PCR machine.
7, 6, 5, 4.
Exploration performance continues to look good.
My experiment looks at the genetic sequence in space to see if any changes in our genetic sequence might be related to some immune system difficulties that astronauts face. We used this mini PCR machine to make multiple copies of the DNA sequence that we wanted. For astronauts who, especially if we're looking to do long duration space flights in the future, the International Space Station, while it's definitely far away, it's much closer to Earth, much more connected than a Mars mission or a deep space mission. So by understanding these markers, we can possibly then understand more about the immune system in space and potentially keep astronauts healthier.
You know, we see a couple of processes in astronauts that concern us about a Mars mission someday. One is that we see suppression and changes in their immune system. Another is we see a variety of patterns that look a lot like aging on Earth, and radiation damage is one thing that can also induce those problems. So this is a great experiment in putting those two things together and taking a look at what's really going on in the DNA.
Just knowing that maybe I'm not in space yet, but a little piece of me is, and not only is a little piece of me going to space, it's also potentially helping the future of space travel, the future of mankind's. That's a really powerful thing to me, and I can't wait to watch that rocket launch and know, there we go.
3, 2, 1.
Ignition. Here it goes. Liftoff.
So now we wait. Now we wait for it to come back and see what happens then.
Of course, I still love you. How's AOS?